A. There was a question. Let me get some scratch papers.
Okay.
Oh my god. Wait. Scratch papers. Okay, where is the number? Yeah, I'm not trying to extend the time so the video will be long. I'm really looking for scratch papers.
You have a pen for me?
Yeah, I'm getting pencil too.
I don't think this one is long.
Huh?
This one is not long.
Yeah, this one is, we didn't really go long. We rather spent a lot of time by explaining. The teacher spent a lot of time by explaining rather than spending a lot of time. Oh, let me see. Okay, perfect. I have only one pencil, so we're using both.
Okay.
The question was, suppose that root of 2 is... It's okay. The question was, suppose root of 2 is rational.
Okay.
Yeah, and then...
We know that a rational number is it's a number who's not written on the form of a fraction, right? That's a rational number.
Rational number is...
No,
like,
it's
yeah,
written on a...
fraction.
Actually, my bad. It's written on a fractional form.
Yeah, and there should be integers, both integers.
Okay.
Okay.
So this
we
suppose that okay, square root of 2 is rational. Okay.
Yeah, we get the number, we call the number, we say that, for example, A and B or whatever.
Okay. Let's say for A and B that belongs to R. That means that are real numbers.
Integers.
Okay.
They
So
should be integers, yeah. Oh yeah.
and integers. Okay. A out of B is rational. That we know.
Yeah.
Okay.
And we suppose the square root of 2 is equals to A over B, where the greatest common divisor of A over B is 1.
1.
So it means the minimum number, like 1 over 2 or let's say 3 over 5, their common divisor is 1. Like the minimum of it, so we cannot simplify it any other ways.
Okay.
So by assuming that, it's gonna be like square root of 2 is equals to A over B, so when we square both sides...
Yeah, we square both sides to remove the square roots, right?
Yeah, so it's gonna be 2 is equals to A squared.
So actually it's like the square root of 2 minus... No, is equal to... Yeah, because we assume that it's a rational number.
Yeah.
It's equals to A out of B, right? So let's square this.
Okay, it's gonna be 2.
So it's gonna be 2 equals to A squared out of B squared. Okay.
Okay, then if we try to leave the cross multiplication, so it's gonna be 2B squared is equal to A squared. So by this rule, it means that 2 divides A squared. 2 divides A squared, because if you like 2b is equals to A squared, it means that 2 divides A squared. A squared is equals to 2 times any integer, right? B is any integer. So if 2 divides A squared, it's the same thing as 2 divides A. Because it's...
Yeah.
So we cannot say that 2 divides... So A squared and like the A has a divisor, is divisible by 2, but we assumed that their greatest common divisor is 1. So this is contradiction. Okay. So our assumption is wrong. So we prove that square root of 2 cannot be irrational. So it is irrational.
So it's irrational because actually when we when we try to solve this equation, we found 2 can divide like 2 is divisible by A squared, right?
Yeah. The same thing we can prove by using B. we can say that A is equals to 2C because A is divisible by 2, right?
Yeah.
A is equals to 2C, and if you put the 2C instead of A, like A square, if you make it square, so it's gonna be 4C square when we square it, so it's gonna be 2B square is equals to 4C square. Okay.
Yeah.
From here, if you put, for example, A is equals to 2C,
Okay.
we found that 2 divisible by A, so A is equals to 2C. So if we square this, it's gonna be A square is equals to 4C square.
Okay.
Got it? So we substitute for A square here. It's gonna be 2B square is equals to 4C square. We put it instead of A.
Okay. Like we found the value of A kind of.
Yeah, kind of found the value of A. We substituted. So by this one, we find that B square is equals to 2C square. So it means that 2 divisible by B as well.
Okay.
So it cannot be true because we said that their greatest common divisor is 1, which is contradiction, which is our assumption is false. Therefore, the square root of 2 is irrational. Basically what the teacher said. Oh, what? This is the end of slides? What did you study before though? No, we studied something else as well, right?
No, I think we finished the last. How do you call it? We finished the last slides that he sent already because we didn't finish that. We had a small one to do the Emma part, the Emma part. You remember the last one that we did, right? The last part that we did.
What was it?
The last class that we had.
Today, on
No,
Monday.
yeah, on
last,
Monday.
Okay. What was it?
Sunday, what we did. We did almost all.
Oh yeah.
And then we left it. There was a small part that was not down yet.
Yeah.
So we need to go to the last slide.
This is the last slide.
No.
Oh, okay. Got you. Oh, these things. Wait, I think it was these things. This one.
Yeah. The lemma.
Which lemma? Oh yeah, lemma. Oh, I see what you mean. Let n be an integer and p be a prime number such that p is divisible by n squared, then p is divisible by n. The theorem that we proved right now. We used it over here.
Yeah.
If you want to prove this by contradiction, suppose that p divisible by n squared, but p does not divide n.
No.
Yeah, so if we prove this one, if we cannot prove it, it will be a contradiction, which will prove that the theorem is true. So suppose that p divides n squared, but p does not divide n, then n squared is equals to pk. N squared is equals to pk.
Yes.
Over here. So by this, he said that p does not divide n, and p is
a prime. Yeah, implies that n is divisible by p.
They said it's only gonna work for prime numbers because if you write it in the format where the format that we wrote, that if p does not divide n and p is a prime number, the reverse of it is also true because of the prime number.
Yeah.
So if you go after,
this is the proof.
Yeah, he divided by n both sides. You cannot divide this by
P.
n because p does not divide
For
n.
Yes.
So yeah, n is equals to dp.
Where does the d come from? That's the most thing.
D comes from.
I think. Oh, yeah, I know. I think d is k. Yeah, d is k out of n because k equals to nd.
Yeah.
So let's say k equals to nd.
Yeah.
I mean, the nd I prefer it on that way equals to k. So d equals to k out of n. So that's what we found here.
Yep.
So yeah, that's why he. Okay, now I got it.
Yep. So he made a contradiction that p divides n and p does not divide n by this one. For example, n is equals to dp. It means that p divides n.
Yeah.
But here in the we assume that p does not divide n. So which made a contradiction, which made our first assumption is false. And then yeah, we came to irrational numbers, which we did right now. It doesn't seem like it's gonna take long. Let's go then to the book, solve a couple of questions, and we can finish this session. Discrete mathematics with application.
You're gonna make me feel sick, man.
I think so. I'm very sick, but I'm getting better. I'm eating lemons, bro.
Yeah, you're getting better, but I'm not.
Okay, I'll put it this way.
Exactly. Protect yourself.
The ninja. Bro, when we watch these videos after, I will remember this day. Bro, I was sick. I'll say to myself, I was so sick. Wait, direct conversion.
Actually, is it you who's gonna do the YouTube channel? Or do you want me to do it?
You do it. I'll subscribe it, bro.
Okay. I think I'll make it private.
If you want it.
Actually, you do the YouTube channel because I have already a YouTube channel.
They edit it there.
No, because you interface with my other ones. People would see it. I don't know if you understand.
Yeah, I don't have anyone though.
Yeah, you can create one.
Okay.
Create as fast as you can because I think tomorrow he'll ask for it.
I don't have memory in my phone. If I create it, I'll have to edit from your phone.
Yeah, that's fine. Just create it and edit from my phone. We can edit tomorrow morning.
Yeah. No, let's do it today night.
Okay.
I'll come by your room and do it.
Okay, just knock.
Yep.
Once you did the YouTube channel already.
I have YouTube account. I think I can edit there. Yeah, we did these questions. If you remember, so we did these questions as we go deeper. Yeah, we did these questions. Like if 7 divisible by 34, we finished at for all integers a, b, and c.
I think 27.
Let me see.
27, I said.
For all integers a, b, if a divisible by b. Yeah, we did this one as well, I think so. Which is our topic though? I can't find it. Oh, it's something different. I don't know these examples. We did most of the questions for that chapter.
Yeah.
This is a new chapter, which we didn't.
No, I think we did all the exercises of this chapter already.
I think so. This is mod already. We don't really need to do mod. We didn't study it yet. Yeah, I mean, I think we did it already. Given integer a, b, and c, if a minus b is even, then b minus c is even. What can we say about the parity? What is this? Let me do it bigger. Let me read this. I don't know what is this. What is this?
N. This is n, right? N equals to 70, and d equals to 90. N equals to d times q.
Oh, the teacher today touched upon this one, but I have no idea how to do it. Because we didn't really, it's div and mode. I don't think we passed this one. Day3.
Division and modular, right?
Division and modulo.
Modular is the rest.
Yeah.
Let's say if we say 3 mode, that's like this mode 2 for example, yeah.
1.
It will be 1. But 3, yeah, it will still be 1, but this is the one of the rest.
Yeah.
And this is the one of the result.
Yeah. For the mode it means the rest.
Yeah, the rest, but for the division it means the answer. So yeah.
Yeah.
I think in programming we do the same thing.
Yeah, in programming we use the mode so much.
the mode thing.
So you're studying?
Yeah.
And do you think there is chances you go out?
I don't know.
Tu vas sortir tout à l'heure?
Oui, je dois aller voir ma basse.
Ah, ok.
Okay, we can stop the session now. I think so. I'll add this.
Teacher, we did all the exercises already, so like